everybody, today we are going to learn a very simple and fast method to convert a voltage waveform into its equation in just a few seconds. Many students think this is difficult, but once you know this trick, you will be able to do it very quickly in exams or while solving the problems. Let's begin. Our goal is given a voltage waveform with voltage on the y-axis and time on the x-axis. We want to write its equation. The equation will tell us how voltage changes with time for each part of the waveform. And in this case, we'll use the equation of straight line. We'll use the equation of a straight line y equal to mx plus c, where this y is the dependent variable. It depends on m, x and c. In our case, the y is v of t. X is the independent variable, in our case time t. M is the slope of the line. It tells us how steep the line is. And it can be calculated using the formula del y by del x, or y2 minus y1 divided by x2 minus x1. And this c is the y-intercept, the point where the line crosses the y-axis. Though the topic of this video is to write the voltage equation using a shortcut method, I have implemented two more methods in order to have a very good vision on this kind of problem solving. So we'll see them one by one. We start with method 1. The first step is to identify the segments. So we have identified here the three segments. The first segment is from point 0, 0 to 2, 10, and this first segment is indicated by the red oval. And in this, when you move from the 0, 0 to 2, 10, you are moving upward. So we say that this has a positive slope. And when you go for the second segment, this is indicated by this dark blue oval, right? And here it is actually, this line lies between the points 2, 10 to 6, minus 10. So when you move from this 2, 10 to 6, minus 10, actually we are moving downwards. So here we have the falling slope or the negative slope. And the third segment is indicated by the light blue color oval shape, right? So here this particular segment or the straight line that lies between 2 points, the first point is 6, minus 10, and the second point is 8, 0. This is actually moving upwards. So this has a positive slope. We need to write the equation of straight line for each and every segment, and then we can combine all to have the voltage equation. Okay. So the formula used here is y equal to mx plus c. So we have taken the segment number 1 here, and we know the starting point is 0, 0, and the end point is 2, 10. And we are going to find out m here. So m is indicated as del y by del x in the first method. Okay, so the change in y parameter value. So it starts at this point and it is going upwards here. Y value here is 10, isn't it? This is how to calculate this del y. It is 10 minus the 0 along this y axis. So the value is 10. Then you go for del x. Del x is the change in x value. So when you move from this first point to the second point, you are moving along the x-axis as 0 to 2. 2 minus 0 as the change, so it gives you the value as 2. When you divide this del y by del x, you get it as 10 by 2. So you are getting it as 5. The next one is to find this x. What is x? It is the x-axis. Here it represents the time value, isn't it? So it is t. So the next step is to find the c. So we know that the c is the y-intercept. That means the line where it meets the y-axis. This is the line segment and it meets the y-axis at the point 0, 0. So x value is also 0, y value is also 0. But we are interested in y value only. Okay. So that gives you the c value. C is equal to 0 here. Now we are going to write the voltage equation using the formula y equal to mx plus c, for the time period 0 to 2 seconds. Combining all the equations already we have done like 2, 3 and 4 and substituting them in equation number 1. So we have calculated m as 5 and x we already know it is t, and y is v of t, and c value we calculated as 0. So now v of t is equal to 5t for the time period 0 to 2 seconds. Now we move on to the second segment. Okay, using the same formula y equal to mx plus c, we are going to get it. So we mark the points here. The starting point is 2, 10 and the ending point is 6, minus 10. You may wonder why we don't stop it here itself. That means 4, 0 as the second segment. This is the first point. And why don't we mark here as the second point? That means this alone will be taken as the second segment, and this would be taken as the third segment, and this is the fourth segment. I already told you that this is first segment, 0 to this first point, and 1 to 2 as the second, and 2 to this point number 8, 0 as the third segment. Why don't we consider this alone, that is first point to this point as second segment, and this second point to this point as the third segment? Because when you move from this 1 to 2, it will be having the same slope, right? It is moving downwards and there is no turning points. After reaching 2 only you will be having the turning point, right? When you move from the 0 to 1, you will be having the same slope moving in the same direction. Then only you have this turning point and it turns downwards, and with the same pace it is moving and it reaches this second point. So this is your second segment. At this point too, it turns up again, and so it will be moving with the same pace. That means it has the same slope from 2 to this point. Okay, so you'll be having the third segment. Now let's start writing the equation for the second segment. So we need to find out m. So m values del y divided by del x. So you can take these 2 points. Change in y is, it is from this 10 to this minus 10, right? So when you calculate this del y, this is first taken, this y2 point. So it is minus 10 minus this y1 point, that is this 10. So minus 10 minus of this plus 10 divided by, and this x value is actually changing from this 2 to 6, isn't it? So it is 6 minus 2 along the x-axis. So it is minus 20 divided by 4, that is equal to minus 5. X-axis represents the time, so x is equal to t. So for finding c, we need to extend this line segment upward as well as downwards. When you extend this line upwards, actually it crosses this particular y-axis at the point 20. But if you extend this line downwards, it never meets the y-axis. So this is not the proper way of extending the line. It is enough to extend the line upwards so that it will cut the y-axis at a particular point. So here the point of meeting the y-axis for this line segment is c equal to 20. So now substituting the values of equations 5, 6 and 7 into equation number 1, we make this as m as minus 5, x as t and c as 20. We'll get the voltage equation for y as v of t, that is equal to minus 5t plus 20 for the time period 2 to 6 seconds. So now we have got the voltage equation for the second segment. Now we are moving on to the third segment, and we are going to use the same formula y equal to mx plus c. Here the starting point is 6, minus 10 and the ending point is 8, 0. So we are going to find this m here. M is equal to del y by del x. So the change in the y-axis is here to here, right? So it is moving from this minus 10 to 0 along the y-axis. So you can write it as 0 minus of minus 10. So you'll get it as plus 10. And when you move from this first point to the second point here along the x-axis, you are moving from this 6 value to the 8. So the difference is 8 minus 6. So that is equal to 2. So 10 by 2 is equal to plus 5. And we know that this x. So now it's time to find c. So we have taken this third segment. So it should be extended downwards as well as upwards. But if you extend it upwards, it will not cut or it will not meet the y-axis anymore. So if you go downward or extending this line downwards, it will reach the y-axis or it crosses the y-axis at minus 40. Okay, so the C is minus 40. Here actually I couldn't show you, but anyhow, when we move from 8 to 6 along the x-axis, it reaches from 0 to this minus 10 along the y-axis. So we, for this 2 seconds, value of y-axis decreases from 0 to minus 10. Similarly, when you move from the 6 to 4, it would be reaching this minus 20. So when you reduce the time axis by 4 seconds, here the y-axis value gets reduced by minus 20. Okay, so here again, so we need to reduce 4 more seconds, then only we'll reach this. So at that time definitely it would be reaching the minus 40. This is how we can do the calculation and we can do it. Okay, otherwise if you have the graph sheet, you can extend the line and you can directly visualize where it cuts the y-axis. Otherwise you can go for this calculation. This simple type of calculation, mind calculation, will be actually done in the shortcut method. Okay, so this is your 11th equation. So now combining all these three equations 9, 10, 11, and substitute them in equation number 1. Okay, so y equal to mx plus c for the time period 6 to 8 seconds, m is 5, x is t, and c is minus 40. So you got this voltage equation. Now by combining all these three voltage equations for the time period 0 to 8 seconds, we will get the voltage equation. So v of t equal to 5t, where t lies between 0 to 2 seconds. V of t is equal to minus t plus 20, where t lies between 2 to 6 seconds time period. 5t minus 40, and the t lies between 6 to 8 seconds. Okay, so we got the answer. Okay, now we move on to the shortcut. This is our second method. So for the first segment, we can write the v of t. How we are going to do it? We know that it is actually the line is going from this 1 to 2. That means it is upward. So the m must be positive. So how to calculate the m here? Along the x-axis, it is increasing from 0 to 2. Along the y-axis, it is increasing from 0 to 10. Okay, so 10 by 2 will be your m. So 10 by 2 into t, you put it as, that is your x value, plus this 0 will be the intersection point of this y-axis as well as x-axis. So you put it as 0. So we have written the first voltage equation for the first segment. It's over now. Then now go for the second segment. It is from this 1 to 2, isn't it? So the first point is 2 comma, it is 0, and the second point is, here it is 6 and here it is minus 10. So 6 comma minus 10. Now we have to find out the slope for this case, right? So here it is minus 10 for the second point and first point is 10 for the y-axis. What about the x-axis? X-axis, it is along 2 to 6 seconds. Okay, so you can put it directly like this, minus 10 minus of minus 10. So it becomes, this variation along the y-axis is minus 20 divided by the variation along this one is 6 minus 2 along the x-axis. So minus 20 by 4 into t. So you get the m value as minus 5 into t plus, what about this 20? How do you find the c? That is y-intercept. For that we have to extend this, right? You have to extend this and you have to find it. Instead of going like that, you see here it is 6, right? Corresponding to the second point. Understand that here to calculate the c, we have to move from this 6, that is the second point x value, right? 6 to this 0. Up to this you have to go along the x-axis. Automatically you will get the crossing of this y value. That means we will get the c value, right? Whenever the x value is going from the 6 to 4, 2-second difference is there, and here the y value will be moving from this minus 10 to 0. That means plus 10. Similarly, when you go from this 4 to 2, y value is moving from 0 to 10, again plus 10. Okay, so when you move from this 2 to 0, it would be moving at plus 10. So moving a plus 10 from this 10, you will be getting it as 20. So in order to find the C value, that means that is the y-intercept. How to do it mentally or by looking at this graph, you can do it, right? So it is from this 1 point to 2. So it is going downwards. The coordinate values 6 comma minus 10. So here along the x-axis it is 6. Along the y-axis its values minus 10. Actually we have to in total move up to this 0 from the 6. But I will be doing it in step by step. So first initially we move from this 6 to 4. So initially we move from the 6 to 4 towards left. So it is minus 2 seconds actually, right? At that time, here we reach this point 4. So what is this coordinate value? It is minus, sorry. So it is plus 4 comma this 0. So y-axis value reaches this 0, right? So it is raising minus 10 to 0. So you are having the value of plus 10 along the y-axis. Then we move from this 4 to 2. That means again minus 2 seconds. So we reach this point, right? So when you reach this point, that corresponds to this 1 in the waveform. So this value is 2 comma 10, isn't it? So it is going from this 0 value to this value of 10, that means plus 10 again. So when you move from this 2 to 0, again you have this minus 2 along the x-axis, and this will be moving from this 10 to 20. So plus 10 again. So here we reach the 0, that's it. Okay, so what's the value we reached? We reached 0 comma 20. So we reach the y-axis value, that means this C value here, after traveling minus 2, minus 2, minus 2 along the x-axis. You reach a 0 at the x-axis, isn't it? Where you will be getting this uh, C point. So along the y-axis it is plus 10, again a plus 10, again a plus 10. So you reaches, so initial point here is along the y-axis it is minus 10, plus 10, plus 10, plus 10. Okay, here actually it starts from the 6, right? 6 minus 2, minus 2, minus 2. So you get the 0. Here it is 20 along the y-axis. This is how you got this C value. This is your C. Hope you have understood. Okay, this is the shortcut method. So this value is equal to minus 5t plus 20. So we got it. Now moving on to the second segment, right? So for the second segment, now moving on to the third segment. So third segment is from this first point to the second point. Actually here it is 6 comma minus 10, and here it is 8 comma 0. So we need to travel towards left side, like this we need to travel. Okay, so from 8 you travel minus 2 seconds, right? So you reach this 6 and the y value is 0. We need to go leftwards, so you will be subtracting minus 2 so that you are reaching the 6, right? Initially it is 0 for this y-axis, so you, when this minus 2 is obtained for the x-axis, here you will be reaching this minus 10. Then again you move towards this leftward. Again one minus 2 should, when you go by this minus 2, what happens here? Again another minus 10. It has to go. So it would be coming here at this point, because at the same pace it is going. Then again you go by this minus 2 once more. So what happens? It is minus 10 again. Again you go by this minus 2 value here, so that you will reach 0 here, right? So you reach a 0 point here. along the x-axis. So here again minus 10, because it is going on the same track. So how much it is? It is minus 40. So this is how we obtain the C value, right? We get the C value as minus 40. But what about this M value? And how to calculate this M value? M value, for that M value, the X value changes from the 6 to 8. So the difference is 8 minus 6. Okay, that is along the x-axis. So del x is 8 minus 6, that is 2. So you have to do the mind calculation. Similarly, this value is changes from this minus 10 to 0, isn't it? Y value minus 10 to 0. So minus 10 to 0 means 0 minus of minus 10, so it is plus 10. So that is equal to 5. The M value is a positive one as it is moving upwards. So this is a positive value M. Okay, now easily you can substitute this V of t as 5t minus 40. V of t as 5t minus 40. So combining all these three things, you will get it as V of t equal to 5t, and V of t is equal to minus 5t plus 20. V of t equal to 5t minus 40 for the time period 6 to 8 seconds. Okay, this is how we get the short trick method applied. Then now we move on to the third method. In the third method, we are going to use this formula. Y minus y1 is equal to y2 minus y1 divided by x2 minus x1 into x minus x1. That means we identified 2 points within that particular straight line is available. Okay. Now we go for the segment 1. In the segment 1, the initial point is 0 comma 0. This is taken as x1 comma y1, and the second point is actually 2 comma 10. This is taken as x2 comma y2. Now you can easily substitute, and here this y value is nothing but your v of t, and y1 value is 0, and then y2 value is equal to 10, y1 value is 0, divided by x2 minus x1. X2 value is 2 and x1 value is 0. So substituting here, instead of x the t value, and instead of this x1 you put it as 0. So substituting and doing the calculation, you will be getting this as 10 by 2. V of t equal to 10 by 2 into t. So it is 5t. Okay, for the first segment. So moving on to the second segment. So this point is actually 2 comma 10. This is your x1 comma y1, and here this point is x2 comma y2, and the values are 6 comma minus 10. So just you substitute all these values x1 y1 x2 y2 in this equation, and y as v of t, and this x as t. Okay, so this is v of t minus 10, that is equal to y2 is minus 10 minus y1 is 10 divided by x2 is 6, x1 is 2, and x is t minus x1 is 2. Okay, so it is v of t minus 10, that is equal to, this becomes minus 20 divided by 4 into t minus 2. So v of t minus 10 is equal to minus 5 into t minus 2, minus 5t plus 20. So you got the second answer. This is for the time period 2 to 6 seconds. So we have done it for the second segment. Now you go for the third segment. So for the third segment, you can mark the points. Here the points are x1 comma y1. It is 6 comma minus 10, and for here it is 8 comma 0. That is your x2 comma y2. Okay, now substitute the values here. So it is v of t. So it is v of t. This v of t minus y1 values minus 10. That is equal to y2 value 0. Y1 values minus 10. So minus of minus plus 10 divided by x2 values 8. X1 values 6. So 8 minus 6 multiplied by the t is the x, so x is equal to t minus x1 value 6. Okay, so if you simplify this, we will get this as v of t plus 10, that is equal to 10 by 2 into t minus 6. Then you will get this, and this 10 by t is nothing but 5. So you get it as v of t plus 10 is equal to 5 times t minus 6. So you will be getting this as 5t minus 30 minus 10. So it is 5t minus 40. So when you combine all these things, You'll be getting this as v of t equal to 5t for the time period 0 to 2 seconds, and that is equal to 5t plus 20, that's for the time period 2 to 6 seconds, and 5t minus 40 for the time period 6 to 8 seconds. Okay, so you got all the answers now using the method 3. So hope you have enjoyed all the three methods and you have a clear understanding about framing an voltage equation from the voltage waveform. Thank you.